Okay, so put your data in there, and our next topic that we're working on is sequences, okay? And so we're going to define a few terms here. Many of you can say sequences. A lot of times you want to use the word pattern, but it's a series of numbers or figures that have an increasing or decreasing pattern. Pattern meaning it has like a formula or something you can predict that'll help it come from the next one to the next one. The term is just like the term when we're looking at polynomials and equations. It's which position of the sequence you are looking at. So for example, if I had a sequence that just very simply went 2, 4, 6, 8, 10, oops, I put 9, 10, right? These are its terms. So this would be your first term, your second term, your third term, and then I might say find the 15th term. So it's just the position that you want to find. Okay. All right. Infinite sequence. Infinite is like the one I have above here. It's a sequence that goes on forever. Has no ending. And that's what those dots, oh, I can't spell. That's what those dots mean above. Like if I have a sequence that goes 1, 3, 7, 12, dot, dot, dot. These dot, dot, dots mean it just goes on and on and on and on, right? A finite sequence is the actual opposite. A finite sequence means a sequence that has an end. Uh-oh, I bet my head's in the way on this. Sorry. Let's move that up. So if I were to look, if I had a sequence that looked like this, 3, 6, 9, and I said find the 7th term, that would be a finite because I'm ending it at the 7th term. Or find this sequence to the 8th term or something like that. That's finite. That means it ends at some point. Okay? Pretty simple to start with here. So let's look at a couple of patterns, and then we have to describe the sequence. Okay? So you're going to have some geometrical figures here. So the first thing I want to do is just sort of note what I have. So here I have 1 cube. And then here I can see it increases by, there's 3 cubes. And here now I can see it goes up to 6 cubes. And here I can see, let's see, it's 4, 5, 6, 7, 8, 9, is that 10? 4, 5, 6, 7, 8, 9, 10 cubes. Okay, so then to describe it, I would say the second term increased by 2 cubes. The third term increased by 3 cubes. The fourth term increased by 6 to 10, that's 4 cubes. So you can kind of see the pattern is each one is going up one more set than the one before, right? So this would be a description of this figure. Now I need to make it smaller so that we can see. All right, and so you're going to kind of keep doing this same type of thing. Here we go, get out of my way. Move that up there. To this one below. So the first thing I want to do is just kind of look and see what's happening, okay? So first I can say, well, this has 3 little dashes. Okay, and then here's the 3 dashes I started with here. And you can see they added one more to each side. So now this has 6. Okay, and then this is the figure before. It had these 2 dashes and these dashes, and then it added 3 more, so we can say it's 9. So we can see it's adding a dash to each end each time, so it's increasing by 3, right? So in this case, because it's the same thing over and over and over again, I can say each figure increases by 3 dashes of the previous figure. So instead of writing it all out, because it's increasing 3 every single time and not a different number, I can just sort of simply state it that way. So let's see how you guys do. Let's see if you can describe what's happening in this figure, and then describe what's happening in this figure. And we are done.